Hi everybody. How are you all? Hope you doing great. Welcome back to today's session of learning mathematics with me. Before beginning, I would like to request you please subscribe the channel Tangent Academy. Also like the video and share it with friends too, because you will get one math problem video every day. First of all, first of all hearty congratulations to all the countrymen on the eve of Republic Day. I apologize for the inconvenience felt by you all because I could not able to maintain to produce video regularly according as I assured that I will upload a new math problem video every day. Due to some personal reason, I could not able to do so. So I again apologize with you all and request you to please subscribe my channel Tangent Academy. I am taking a MCQ problem today from complex number, and here is the problem. If alpha and beta are distinct means different. If alpha and beta are distinct complex numbers, then value of absolute value of beta minus alpha divided by 1 minus alpha bar beta will be option 1 is -1, option 2 is 1, option 3 is 0, option 4 is none. Very interesting problem. So let us, I am going to solve this problem. Before solving it, I would like to discuss some properties. By using that properties, I will find the value of absolute value of beta minus alpha divided by 1 minus alpha bar into beta. In case of complex number, we know that complex number is in the form of z is equal to x plus iy, where I is equal to under root minus 1, which is imaginary quantity. Z is equal to x plus iy, then z bar is treated as mirror image of this very point xy with respect to x-axis. Because suppose there is the in complex plane imaginary plane, let xy be any point in this point. If we treat x-axis as a plane mirror, then its image will be x minus iy, only y sign of y coordinate changes. So conjugate of any complex number can be, any complex number x plus iy can be written as x minus iy and so on. This middle portion sign will be changed. Let us take some property which will be useful to solve this problem. Absolute value of z square, z into z bar. This is very important property. Also quotient of two complex numbers z1 by z2 whole bar is equal to Z1 bar divided by Z2 bar. That is the conjugate of quotient of Z1 and Z2 is equal to their individual conjugates. Similarly, in case of product, Z1 into Z2 whole bar is equal to Z1 bar into Z2 bar. Also, there is a property which will be used. Z bar to whole bar is the complex number itself. That is conjugate of conjugate is equal to the complex number itself. Please remind these formulas, these properties in mind, keep in mind so that we will understand the calculation of this expression. Now let us move. So we will use the first property. We can take the whole this expression as a complex number z. So b minus alpha 1 minus alpha bar beta whole square, that is z square, may be written as z into z bar. Z into z bar whole. Keeping in mind this property, modulus of z square is equal to z into z bar. So I have written, let us treat it as a complex number z, then z square may be written as z into z bar. Modulus of z square is equal to z into z bar. Further, we can write it beta minus alpha 1 minus alpha bar in beta. And we have previously seen that z1 by z2 whole bar may be written as z1 bar divided by z2 bar. So keeping in mind this expression, second expression may be written as beta minus alpha bar divided by 1 minus alpha bar beta whole bar. Proceeding in this way, we know that z1 into z2 whole bar may be written as z1 bar into z2 bar. So this product will be beta minus alpha divided by 1 minus alpha bar beta into z1 minus z2, z1 minus z2 also. This property will hold good. z1 minus z2 whole bar can be written as z1 bar minus z2 bar. Keeping this property in mind, it can be written as beta bar minus alpha bar divided by 1 minus alpha bar whole bar into beta bar. This property z1 into z2 whole bar may be written as z1 bar into z2 bar. In the similar pattern, z1 bar into z1 minus z2 whole bar may be written as z1 bar minus z2 bar. That is, conjugate, whole conjugate of beta minus alpha can be written as conjugate of beta minus conjugate of alpha. Also alpha has already conjugate, so when this sign applied on this alpha bar, this can be written as alpha bar to whole bar into beta bar. According to this product property, z1 bar into z2 whole bar is equal to z1 bar into z2 bar. And we have already seen that z bar to whole bar conjugate of a complex number to whole conjugate is also equal to the complex number itself. So this value may be written as beta minus alpha divided by 1 minus alpha bar beta into beta bar minus alpha bar divided by 1 minus alpha into beta bar, alpha into beta bar. Now we will go through plain multiplication, simple multiplication, and simple multiplication. When we multiply beta into beta bar, we will have beta into beta bar, beta into alpha bar minus beta into alpha bar minus alpha into beta bar. This fourth, and minus plus alpha into alpha bar. The second term, 1 into 1 gives you 1 minus alpha beta bar, 1 minus alpha beta bar into beta minus alpha bar into beta, minus into minus again plus alpha bar into beta bar. This will be final multiplication. So producing in this way, we know that alpha into alpha bar is equal to modulus of alpha whole square, and beta into beta bar is equal to modulus of beta square. According to this property, modulus of z square is equal to z into z bar. One more thing is given in the question already, I can't write earlier. Absolute value of beta is equal to 1 is given. Absolute value of beta is equal to 1 is already given. So beta into beta bar can be written as modulus of beta square minus beta alpha bar minus alpha beta bar. Again we can write alpha into alpha bar is equal to modulus of alpha square, modulus of alpha square, and this can be written as 1 minus alpha beta bar in the denominator minus alpha bar beta. Again alpha into alpha bar may be written as modulus of alpha square into modulus of beta square. But as earlier given that modulus of beta is equal to 1. Earlier given that modulus of beta is equal to 1. So the given expression yields 1 minus beta alpha bar minus 1 minus beta alpha bar minus alpha beta bar plus modulus of alpha square divided by 1 minus alpha beta bar minus alpha beta bar plus modulus of alpha square. Since because modulus of beta is equal to 1, so modulus of beta square will be 1. Now we observe that these two expressions are same in the numerator and denominator, so it can be cancelled out and it will give you value equal to 1. It will give you value equal to 1. So we get left hand side is modulus of beta minus alpha divided by 1 minus alpha bar beta whole square is equal to 1. Therefore we come to the conclusion that modulus of beta minus alpha is equal to 1 minus alpha bar beta is equal to 1, not plus minus 1, because absolute value can't be negative. So modulus of beta minus alpha divided by 1 minus alpha bar beta is equal to 1. Then your correct option will be option 2, whose value is 1. So I hope that this video will be helpful for you. Like it, share it. I will meet you with a new video next day. Till then, take care and bye.